Welcome to the Innovation Unpack Deep Dive. Today, we are looking at something that is highly speculative, totally unvalidated, but honestly, it's an absolutely groundbreaking strategy dossier.
It really is.
It's authored by Mike Boysen, and it's called the Venture-Proof Analysis. And what it attempts to dissect is, well, it might just be the largest invisible black hole in healthcare technology today.
Yeah, that's definitely not an understatement.
Right. And I want to start by framing this massive paradox that the dossier puts right front and center for you. Because, look, we live in an era where healthcare is supposedly completely digitized. I mean, we don't use manila folders anymore. We have patient portals. We have mobile apps tracking our heart rates. We have gigabytes of data attached to our medical identities.
All stored on these massive servers, yeah.
Exactly. And yet, when your medical history is transferred from one hospital to, say, a competing hospital across town, anywhere from 15 to 30% of your patient records they simply vanish. Poof.
Gone.
They devolve into what this dossier calls inert text. And this isn't just a minor glitch. It is a $340 billion systemic failure.
That number is just staggering when you really think about it.
It's mind-blowing. And the proposed solution in this dossier requires us to do something radical, to structurally invert the entire architecture of medical data.
Yeah, and it is a profound paradox. But before we get swept up in the whole, visionary aspect of structural inversion...
But it's very tempting.
It is. But we need a serious reality check on the ground floor first. Because the mission of our deep dive today is to explore this failure of what the industry calls semantic interoperability.
Right.
And we have to approach this recognizing the immense gravity of the current legacy systems. I mean, you can't just rip the semantic layer away from proprietary electronic health records or EHRs overnight.
Right, because these aren't just like small software tools.
Exactly. We are talking about entrenched giants.
Sure.
You look at companies like Epic, they hold a $40 billion market cap with, decades of deep institutional integration in hospitals worldwide.
Decades, yeah.
Oracle Health has a massive global footprint too. These are monolithic, highly complex architectures. So to really understand the radical nature of the venture-proof analysis, we first have to rigorously unpack the severe limitations of what exists today.
We have to figure out the why.
Right. We have to understand why that data turns to inert text in the first place before we can even talk about fixing it.
That's a fair point. We need to define the mechanics of the failure before we can, evaluate the cure. And to do that, the dossier takes us back to the historical context of the early 2000s.
Right, to the push.
Yeah, there was this monumental industry push to digitize everything. I think the assumption was that once the records were on screens instead of paper, the whole problem of medical communication would be solved.
That was the dream anyway.
We laid down the digital highway, so to speak.
We laid the highway, yes. But the core thesis of this dossier is that the entire healthcare IT industry fundamentally conflated two very different concepts.
Okay.
They confused syntactic data transport with semantic data comprehension.
Syntactic transport versus semantic comprehension. Okay, wait, let me try to translate that into an analogy for you listening, because it's a crucial distinction.
Go for it.
If we think about sending a digital package, say an API request or even just an email, the syntax is the envelope. It's the routing protocols, the timestamps, the metadata, the structural formatting that ensures the packet gets from server A to server B without dropping any bits.
Right. It's the physical delivery mechanism.
Exactly. If the syntax is correct, the email arrives. The semantic, that's the payload inside. That is the actual body of the email. So what this dossier is arguing is that we spent, 20 years perfecting the envelope?
Easily 20 years.
But when the receiving hospital finally opens that envelope, the letter inside is written in an ancient localized dialect that they literally cannot read.
That is a highly, highly accurate way to visualize it. And the mechanics of this failure, they're basically hiding in plain sight within our current data standards.
How so?
Well, for years, the industry relied on standards like HL7v2 and, more recently, FHIR Fast Healthcare Interoperability resources.
Right. FHIR is everywhere now.
It is. But these standards are purely structural. They dictate the shape of the envelope. They say, put the patient name here, put the date of birth here, put the clinical observation here.
Okay, that sounds good, though.
It does, until you look closer, because inside that observation field, the actual data remains locked in localized, highly proprietary clinical vocabularies that are created by the monolithic EHRs themselves.
Wait, let me make sure I'm grasping the technical reality here, because if I'm a patient being transferred from, say, a hospital running Epic to a hospital running Oracle Health, the transmitting system sends my file.
Yes.
And the structure, the FHIR payload, is perfectly compliant. It arrives safely, right? Syntactically, yes. The transfer is a complete success. The receiving server accepts the JSON payload, it parses the structure, and it routes it to the correct patient chart.
Okay.
But then Oracle's pharmacy module encounters a specific drug code in that payload. Let's say the code is an internal proprietary string, something like ME-88421.
Just a random alphanumeric string.
Exactly. Oracle's system has absolutely no computational understanding of what that string represents.
None.
None. Because that string isn't mapped to a universal shared ontology like RxNorm or SNOME-CT. It is a localized dialect that is completely unique to the transmitting hospital's specific database configuration.
I have to frown at that. I mean, I want to push back a little here.
Sure.
Because if the entire point of the HealthTech Act and the literally billions of dollars the government poured into these meaningful use mandates was to make systems talk to each other.
Right. Why wouldn't the standards bodies just force everyone to use the same universal dictionary? Why is the industry still speaking in these proprietary dialects today? Is it just incredibly old, clunky code, or is there something, I don't know, more intentional happening here?
It's entirely intentional. It's market mechanics.
Really?
Oh, yeah. The dossier argues quite firmly that this isn't a software bug. It is a business model.
Wow.
Incumbent legacy vendors are built on an architecture of data gravity. And the entire goal of data gravity is to hoard data and maximize vendor dependence.
So they want you trapped.
Exactly. Because if a legacy EHR vendor controls a proprietary semantic layer, if they are the ones who define the localized dictionary, it makes it astronomically expensive and painful for a hospital network to ever migrate to a competing vendor.
Oh, I see. So the lack of translation is actually an intentional moat.
Yeah.
They are more than happy to sell the transportation layer because, well, the government mandates it, but they intentionally withhold the comprehension layer to preserve their monopoly.
You hit the nail on the head. They rely on the sheer weight and messiness of your clinical data to keep you locked into their ecosystem. The cost of translating decades of proprietary localized codes into a new system is often so high that hospital CIOs simply abandon the idea of switching vendors altogether.
That is, wow, okay. So if the envelope is essentially useless without a translator, I want to pivot to the actual human and financial cost of this semantic blindness.
Yeah, we have to talk about the fallout.
Because this dossier claims it's costing the industry $340 billion annually. And we aren't just talking about IT administrators being annoyed by database migrations here. We are talking about severe clinical consequences.
Extremely severe.
What happens at the bedside when that proprietary code arrives and the receiving system just can't read it?
Well, the consequences happen in fractions of a second. Because the receiving system cannot compute that proprietary string, it defaults to treating the data as inert text.
Inert text, meaning the computer just renders it as like a dumb string of alphanumeric characters on a screen rather than a computed medical concept.
Precisely. It becomes completely invisible to the hospital's clinical decision support algorithms, the CDS.
Oh, that sounds bad.
It's terrifying. Let's say you're the patient, and you have a severe allergy to a specific class of antibiotics, and you are also on a complex blood thinner.
Okay.
If the incoming codes for those medications show up as inert text, the CDS engine cannot fire an alert when a physician accidentally prescribes a contraindicated drug.
Because the computer literally doesn't know you're on a blood thinner.
Exactly. The safety net disappears completely. The dossier highlights a staggering statistic here. 68% of medication interoperability failures occur exactly at this moment.
68%?
Yes. When an EHR's pharmacy system attempts to receive and interpret outside data, that semantic loss leads directly to dangerous drug interactions and severe dosage errors.
68% of pharmacy interoperability failures. That is genuinely terrifying.
It is.
And from an economic standpoint, the dossier points out that this semantic loss forces clinicians into practicing defensive medicine.
Oh, absolutely.
If a doctor in the ER is looking at a screen full of unmapped, inert lab results from an outside clinic, and they know they can't trust the data because the system hasn't validated it against their internal ontology, What do they do?
What else can they do? They order the tests again.
Right.
They run another CBC. They order another MRI. They draw your blood a second time.
And the math on that scales brutally. The dossier calculates this redundant testing costs up to $39 per patient encounter.
Which, I know, $39 sounds minor.
Yeah, out of context it does.
But until you multiply it by the millions of patient encounters happening across the country every single day,
Oh, right.
that defensive redundant testing is a primary driver of the $340 billion in annual industry waste. It's a massive financial leak. And it exists entirely because the systems refuse to share a common dictionary.
It's infuriating. But, the friction doesn't even stop at reading the data. One of the most fascinating bottlenecks the dossier outlines is what it calls the right gap.
Ah, yes, the right gap.
I really want to dig into this because we always hear about APIs opening up healthcare. Oh, the API economy is here. But there is a fundamental difference between extracting data and pushing data back in.
It's arguably the most frustrating bottleneck for third-party researchers and clinical innovators today. Look, over the last few years, government mandates did force legacy vendors to open up their read APIs.
Right.
Using FHIR, you can now reliably execute a GET-T request and pull a patient's data out of a legacy EHR.
So a third-party application, say a specialized oncology algorithm built by a startup, can pull the patient's history and analyze it.
Yes. But healthcare isn't just about reading data, right? It's about acting on it. The right gap refers to the severe restrictions placed on POST and PUT requests. The ability to seamlessly push new data, like an updated care plan or a new medication order, back into the patient's official chart. Legacy vendors heavily throttle this capability.
But why? If the third-party algorithm finds a critical insight and needs to update the chart to save the patient's life, why would the vendor block that?
Well, the legacy vendors cite liability protection and the risk of database corruption.
Of course they do.
Right. They argue that allowing third-party tools to write directly to the EHR could overwrite critical clinical data or bypass internal safety checks.
I mean, I guess that sounds plausible on the surface.
On the surface. But the dossier argues this is an artificial bottleneck designed specifically to kill third-party innovation. Instead of open, standardized write access, the legacy vendors force third-party developers to navigate these incredibly convoluted proprietary webhooks. And then they charge predatory API tolls for the privilege.
Okay, how predatory are we talking? Give me some context.
We are talking about fees that literally destroy the business models of smaller startups. Epic, for instance, has been known to charge around $3 per million API calls, just for basic extraction.
Just to read it.
Just to read it. When you move into write operations, the costs and the bureaucratic hurdles multiply exponentially. It essentially forces hospitals to buy the legacy vendor's own, often inferior, internal modules rather than integrating best-in-class third-party tools.
Because the hospital can't afford the API fees to use the third-party tool.
Exactly. It prices out the competition.
I see the logic, but it's incredibly cynical.
Very.
So if the system is this broken, I mean, if we are bleeding billions of dollars in redundant tests, risking patient lives with inert text, and throttling innovation with these crazy API tools, why is the general narrative in health tech so optimistic?
That's the million-dollar question.
Right. If you go to any major conference, there are keynotes promising that true interoperability is just, around the corner. The dossier explicitly demands that we challenge these industry hunches, so I think we should systematically cut through the noise.
We must. The industry is currently operating on 3 widely held yet fundamentally flawed beliefs, and the dossier surgically deconstructs every single one of them. Let's start with the most pervasive one. The belief that widespread FHIR adoption equals true interoperability.
Okay, wait, I'm a bit skeptical. Walk me through the mechanics of why that is false. Because everywhere you look, FHIR is touted as the holy grail.
I don't know.
The government pushes it, developers love it because it uses modern RESTful web services and JSON formats instead of the old, clunky HL7 pipe-delimited strings. If 2 hospitals are both using the exact same FHIR structure, how is that not true interoperability?
Because, again, FHIR standardizes the structure of the data. It does not standardize the vocabulary of the clinical concepts.
Okay, unpack that a bit more.
Think about a standard FHIR resource, like an observation resource for a lab test. FHIR guarantees that the JSON payload has a designated field for the patient ID, a designated field for the timestamp, and a designated field for the test result.
Right. It defines the schema as the blueprint.
Exactly. But FHI does not strictly enforce the specific code set used inside that result field.
Oh.
So if Hospital A creates a perfectly structured, totally valid FHIR payload, but fills the result field with an internal proprietary code for, say, a hemoglobin A1C test, instead of the universal LOINC code.
The receiving system at Hospital B parses the JSON perfectly, looks at the code, and still has no idea what the test actually is.
Precisely. Relying solely on FHIR without enforcing strict semantic ontologies creates what the dossier calls a lowest common denominator exchange.
A lowest common denominator exchange?
Yeah. It satisfies the auditors because the hospital technically proved they can send and receive FHI APIs. They check the box. But it is clinically unsafe at the bedside because the data remains uncomputable.
It's an illusion of progress. That makes perfect sense. Okay, let's move to the second industry hunch the dossier challenges. And this is the one I really want to push back on.
I figured you would.
Yeah, it's the idea that generative AI and large language models will replace rigid terminology servers. Now, the dossier dismisses this, but I have to play devil's advocate here.
Be my guest.
LLMs like ChatGPT are phenomenal at parsing messy, contextual data. I mean, we've all seen it. If the problem is translating an ancient localized dialect, isn't that exactly what neural networks are designed to do? Why can't a hospital just plug an LLM into their database and let it dynamically map all these weird proprietary strings to the correct universal codes?
Because probabilistic AI cannot be trusted with deterministic clinical data.
What?
It is a fundamental mismatch of computer science principles. We must challenge this AI hype relentlessly.
But LLMs understand context better than any rigid database ever could. I mean, they can read the doctor's notes surrounding the code.
They don't understand context in a human or clinical sense, though. LLMs are statistical engines. They plot vector embeddings and predict the next most likely token based on massive training data sets. The dossier points to rigorous empirical experiments proving that off-the-shelf LLMs are highly unreliable for clinical ontology mapping.
Unreliable how? Are they just, failing to find the codes? Because a database lookup fails, too, if the code isn't there.
It's worse than that. They hallucinate non-existent codes that look statistically plausible.
Oh, wow.
Or they return overly broad concepts that pass a surface-level visual review but fail disastrously under clinical scrutiny. Let's look at the mechanics of a hallucination in this context.
Okay.
An LA might look at a proprietary string for a specific medication. Because the text string shares statistical similarities with both an adult dosage form and a pediatric dosage form in its training data, the LM might confidently map the string to the pediatric ICD-10 or RX norm code.
Just because the words appear near each other frequently in the vector space?
Exactly. It's just doing math on word proximity.
Mm-hmm.
And the consequence is that a child suddenly receives 10 times the correct dose of a medication.
God.
In medication reconciliation, your acceptable hallucination rate is exactly 0. A generative AI is, at its core, a probabilistic guessing engine. You cannot replace a deterministic, rigid terminology database like SNOME-CT, where every concept has a permanent, mathematically defined relationship to other concepts, with a guessing engine.
I see. So AI might be useful for drafting an email where a wrong word is just a typo. But in a database mapping exercise, a wrong guess is a legal clinical error. 0 false positives is the only acceptable baseline.
Exactly. AI can be an incredible assistive tool, which we will actually discuss when we get to the proposed architecture.
Yeah.
But the rigid deterministic database is a non-negotiable requirement for clinical safety.
Okay, I concede the point. That's a vital distinction. So the third hunch the dossier targets is the belief that legacy vendor cloud offerings represent a shift toward open architecture. We are seeing vendors offer these hosted SaaS models, SaaS things like Epic Garden Plot or Oracle Health Cloud. The narrative is that by moving to the cloud, these monolithic vendors are finally embracing modern, decoupled interoperability.
That is definitely not an architectural revolution. No, it is a highly effective, monopolistic survival tactic. The dossier completely deconstructs this narrative.
How so? I mean, a cloud-hosted SaaS model sounds inherently more modern than an on-premise server rack sitting in a hospital basement.
It's modern hosting, sure, but it is the exact same locked-in architecture. These light cloud offerings are essentially walled gardens. They are specifically targeted at capturing mid-market hospitals, the regional networks with maybe 5 to 15 facilities.
Why target them specifically? Why not the massive research hospitals?
Because mid-market networks are the most vulnerable to defection. They have enough capital to upgrade their systems, but they don't have the massive IT budgets required to build custom integrations. If a mid-market hospital realizes the limitations of their legacy system and decides to move to a truly decoupled, headless EHR, an architecture where the data layer is totally separate from the application layer, the legacy vendor loses that client forever.
So the legacy vendors offer a cheaper, cloud-hosted version of their monolith to basically intercept that defection.
Precisely. They offer a lower upfront cost and handle the hosting for you, but the data remains firmly trapped within their proprietary semantic ecosystem. The data gravity hasn't disappeared at all. They've just moved the lock-in from a server in your basement to a server in their proprietary cloud. It completely prevents the industry from moving toward true vendor-agnostic interoperability.
Man. Okay, this is where the deep dive gets incredibly compelling, because if the legacy standards like FHIR aren't enough on their own, and if we can't just unleash basic AI hallucinations on the database, and if the vendor SaaS clouds are just traps to maintain monopolies, what is the actual structural solution? Where is the viable path forward?
The solution proposed in the venture-proof analysis requires us to change fundamentally where the comprehension happens.
And this brings us to the core thesis, the paradigm shift.
Yes.
The dossier calls it structural inversion. And I want to explore this deeply because it completely changes the power dynamics of healthcare IT. It's so elegant.
It really is. Structural inversion means decoupling the data from the proprietary applications that generated it. Currently, the EHR is both the data entry tool and the brain that attempts to comprehend the data.
Right.
The dossier argues we must pull the brain out. We must move the semantic layer outside the proprietary EHR entirely and place it into a neutral, vendor-agnostic data fabric.
It's a brilliant concept. You strip the legacy vendors of their data gravity moat entirely. If the semantic layer, the universal dictionary, lives in a separate, independent cloud fabric, then the legacy EHR simply becomes a dumb terminal.
Exactly.
It's just a user interface for doctors to type into. The actual computational understanding of what those keystrokes mean happens in a neutral zone that neither the hospital nor the legacy vendor owns.
That is the architectural ideal. It prevents any single vendor from holding a hospital's data hostage. But we have to get into the weeds of how this actually functions. Because as we just discussed with the AI hallucinations, building an external semantic layer safely is incredibly difficult.
Right. The execution is everything.
Exactly. How do we ensure this vendor-agnostic fabric doesn't just devolve into the same chaotic AI hallucinations we warned about earlier?
If we are pulling the brain out, we need absolute guardrails.
We do.
The dossier breaks down this new architecture into a very specific spatial concept with 3 critical components. Let's unpack the first piece, the LLM mapping suggestion engine.
All right, let's visualize the workflow here. Data arrives from an outside hospital. It contains a messy, localized proprietary code. Perhaps it's some obscure abbreviation for a generic blood thinner.
Okay.
The LLM acts as the first line of defense. This is where we use AI specifically for its strengths, as a fast, probabilistic engine capable of parsing messy context.
So the AI looks at the string, looks at the surrounding clinical notes, the unstructured text, and makes an educated guess. It says, based on my vector analysis, I believe this proprietary abbreviation maps to this specific universal RX norm code.
Exactly. It generates a mapping suggestion, but because it is probabilistic, we assume it might be hallucinating. The LLM is never, ever allowed to write data directly to the patient record.
It has no write privileges.
None. Instead, it hands its suggestion to the second architectural component, the ontology gatekeeper.
The ontology gatekeeper, this is the deterministic guardrail. I want to make sure I understand the mechanics here, because this is the crucial part. This isn't just another AI checking the first AI's work, right?
No, absolutely not. That would defeat the whole purpose. The gatekeeper is a rigid, rule-based computational engine. It is directly connected to official, universally maintained databases. We are talking of the National Library of Medicine's RX norm or the Regent Street Institute's LOINC.
So think of it like a strict API schema validation, or like a cryptographic checksum. The AI suggests a mapping payload. The gatekeeper receives that payload and runs a deterministic query against the official database.
Yes.
If the exact code suggested by the AI does not literally exist in the official codebook, what happens?
The gatekeeper throws a 400 bad request error, conceptually speaking.
It just kills it.
It blocks the mapping instantly. There is zero tolerance for statistical closeness. If the code isn't a perfect verifiable match to the rigid ontology, It does not pass. It enforces 100% precision on known codes. The AI proposes, but the deterministic gatekeeper disposes.
Okay, that solves the hallucination problem entirely. The AI gives you the speed of parsing messy text, but the gatekeeper provides the mathematical guarantee of safety. But wait, that leaves a critical gap. What happens to the mappings that the gatekeeper rejects? Or what if the AI is completely confused by a brand new proprietary code and refuses to even make a suggestion? Does the data just drop?
No, it doesn't drop. And that brings us to the third and perhaps most important component of the architecture, the externalized exception queue. This is what the dossier refers to as a human-in-the-loop system, or HITL.
Wait. If we are still relying on human informaticists to map codes, aren't we just back to the original bottleneck? I mean, the whole reason the system is failing today is because humans can't keep up with the sheer volume of proprietary data.
This is where the dossier introduces the concept of labor inversion. We really have to look at the workflow of a clinical informaticist under the old, failing system to appreciate this.
Okay, lay it out.
Today, because there is no automated gatekeeper, highly trained, six-figure salaried informaticists spend 60 to 70% of their day manually acting as human dictionaries.
Just doing data entry, basically.
Yes. They map routine, standard terms over and over again. They map Tylenol to acetaminophen 1,000 times a week. It is a massive waste of human intelligence and hospital resources.
Ah, I see the shift. With the structural inversion architecture, the LLM and the gatekeeper handle all those routine mappings automatically.
Exactly. The system automatically maps and approves 95% of the incoming data at machine speed. The human informaticists are completely removed from the routine workflow. They only interact with the externalized exception queue.
So they only review the 5% of codes that fail the gatekeeper.
Precisely.
That fundamentally changes the job description. Humans are no longer the execution bottleneck. They are the high-level governance layer for edge cases.
Exactly. Instead of wasting time on routine terminology, the informaticist uses their advanced clinical judgment to solve complex, rare anomalies, like, say, a bizarre, locally compounded medication from a specialty pharmacy that the AI has never encountered. They solve the exception, map it correctly to the ontology, and the data moves forward.
The elegance of that workflow is undeniable. You are maximizing the efficiency of both the machine and the human. But I have to bring us back down to reality for a second here. Building this external semantic layer, deploying LLMs, maintaining deterministic gatekeepers, and shifting all these workflows, that requires a massive upfront investment. Does this actually make financial and operational sense for a hospital network to do this?
This is where the dossier's economic analysis becomes critical. It outlines a phased approach, starting with Pathway B, which represents sustaining innovation for a single mid-market hospital network. And to prove the economics of Pathway B, the dossier introduces a concept known as the Jevons elasticity factor.
The Jevons paradox. Oh, that's a classic 19th century economic theory. For those listening who might not be familiar with it, William Stanley Jevons observed that when technological improvements increased the efficiency of coal-powered steam engines, the overall consumption of coal actually skyrocketed rather than decreased.
Exactly. In standard economics, if you make a process cheaper and more efficient, the demand for that process often surges so dramatically that it wipes out any cost savings. It's highly elastic.
Right.
But the venture-proof analysis confirms that in the context of healthcare semantic mapping, the elasticity factor is highly inelastic. Specifically, the dossier cites an E-value of 0.5.
Let me translate the impact of that math for you. It means that saving money on mapping medical codes doesn't induce a massive spike in volume.
Right.
If this new architecture makes it, say, 60% cheaper and faster to reconcile a patient's medications during a hospital transfer, a hospital isn't suddenly going to order double the amount of patient transfers just because the software is cheaper.
No, they won't. The overall volume of patients moving through the system stays relatively stable, governed by actual clinical need, not software efficiency.
Which means the savings actually compound. It creates a bankable efficiency dividend. Because the demand curve is sublinear, every single dollar you save on operational overhead drops straight to the bottom line. You aren't chasing a massive induced volume rebound to make the economics work.
Which is incredibly rare in IT upgrades. And what does that bottom line look like? The dossier claims this architecture yields a $3.20 return on every $1 invested, a 3.2x ROI.
That is a massive number to slide across a boardroom table to a CFO.
It is a massive number, and frankly, I scrutinize any ROI claim over 2x in healthcare IT.
You have to.
You do. The 3.2x ROI is mathematically possible, but the dossier includes a major caveat here. It only works if the hospital performs full, brutally honest cost accounting of their current failures.
What are they missing? What aren't hospitals currently calculating in their baseline?
They systematically ignore the hidden costs of their current manual processes. For example, many hospital CIOs fail to include the massive licensing fees for their internal terminology servers, which can easily exceed $150,000 a year just for basic maintenance.
Just to keep the dictionary updated.
Exactly. Furthermore, they don't financially quantify the 60 to 70% of informaticist hours wasted on routine manual mapping that we just talked about.
They just view it as a sunk salary cost.
Exactly. If you don't establish the true bleeding baseline cost of your current manual failure, your ROI model for the new architecture completely collapses. You have to know exactly how much you are losing to calculate what you've saved.
That makes perfect sense. You can't claim an efficiency dividend if you are hiding the inefficiency off the books to begin with.
Exactly.
Which brings us to the ultimate reality check that the dossier demands before any hospital attempts this. They call it the MVVP, the Minimum Viable Value Proposition.
This is the most pragmatic piece of the entire dossier, and it is absolutely non-negotiable.
Tell me about it.
Before a hospital network signs a massive contract, before they provision the cloud infrastructure, and certainly before they deploy any AI mapping engines, they must manually run a concierge prototype.
A concierge prototype. Explain the mechanics of that. It sounds like a Wizard of Oz proof of concept.
That's exactly what it is. For a strict period of 4 weeks, you use your human informaticists to manually act as the external semantic layer.
Okay.
You take a small, controlled sample of live care transitions, patients moving from outside clinics into your hospital. Your humans intercept the incoming proprietary data, manually run it against the universal ontologies, map it perfectly, and feed it into the clinical workflow.
So you are manually simulating the structural inversion. No AI, no automated gatekeepers, just humans doing the exact workflow the machine will eventually do.
Yes. And the goal is to prove definitively with hard data that correct semantic mapping actually prevents medication errors and triggers the clinical decision support algorithms accurately for those specific patients.
Prove the clinical safety mechanic first.
Exactly. If your highly trained humans cannot manually catch errors using proper ontology mapping, then automating the process with AI and a gatekeeper will do nothing but automate a broken clinical workflow at scale. If you can't prove the value proposition manually, you have no business automating it.
That is incredibly grounded. Prove the physics of the solution in a controlled environment before you build the factory.
Precisely.
But let's assume a hospital does it. Let's assume they run the MVVP, they validate the clinical safety, they deploy the architecture, and they achieve that 3.2x ROI. They optimize their single mid-market network. That is pathway B.
Yes, sustaining innovation.
But where does this structural inversion ultimately lead the entire healthcare industry? Because the dossier doesn't stop there. It outlines a pathway C.
Pathway C is the disruptive vision. It is the ultimate endgame of moving the semantic layer out of the proprietary EHR and into a vendor-agnostic data fabric.
This is where we have to take a visionary leap, because Pathway C isn't just about one hospital saving money. It's about a multi-tenant network effect.
Let's clearly define what multi-tenant means in this architectural context. Under the current broken paradigm, every hospital system is a single tenant. They buy their own isolated terminology server, they hire their own isolated team of informaticists, and they build their own localized mapping tables from scratch.
Everyone is doing the same work in a vacuum.
It is single-tenant overhead,
Yeah.
and it is financially ruinous because everyone is duplicating the exact same labor.
But if the semantic layer, the AI suggestion engine, the gatekeeper, and the exception queue lives in a vendor-agnostic cloud, then multiple health systems can share the exact same infrastructure.
Right.
They become multiple tenants in the same semantic fabric. And this is where the dossier introduces a concept that I find absolutely fascinating: amortizing the exception queue. Walk me through the mechanics of how that works across a network.
This is where the architecture becomes truly elegant. It means we begin to share the human learning across organizational boundaries. Let's imagine a scenario. A human informaticist at Hospital A, located in New York, is working in their exception queue.
Okay, so they're looking at the 5% of edge cases.
Exactly. The deterministic gatekeeper has blocked a weird, highly proprietary code for a newly released, genetically targeted cancer therapy coming from a small regional clinic.
The AI couldn't map it, the gatekeeper blocked it, so it hits the human's desk.
Right. The informaticist at Hospital A uses their advanced clinical judgment, researches the new therapy, determines the exact, correct, universal SNOME TCT code, and solves that complex edge case. They map it, and the data flows into their patient's charts safely.
But because they are operating in a multi-tenant semantic fabric, that knowledge doesn't just stay in New York.
Exactly. That newly validated mapping is instantly committed to the shared gatekeeper database. So 3 weeks later, when Hospital B, located in California, encounters that exact same proprietary code from a similar regional clinic.
The gatekeeper approves it automatically.
Yes.
The human informaticist in California never even sees it in their exception queue.
Precisely. Every edge case reviewed and solved by one informaticist anywhere in the network becomes immediately and permanently available to every other organization in the network. The human effort is amortized across the entire user base.
The implications of that are staggering. It means the cost per mapping actually decreases as the network scales. You are achieving a theoretical physics minimum cost. The more hospitals that join the fabric, the exponentially smarter the shared gatekeeper becomes, and the fewer exceptions any individual human has to review.
It fundamentally alters the trajectory of the field. It solves the safety scalability paradox.
Yeah.
We already know we cannot scale human labor linearly with the massive explosion of clinical data volume. Pathway C ensures that human oversight becomes a diminishing resource requirement rather than a permanent, unbreakable bottleneck.
And think about what this does to the monopolistic power of the legacy EHR vendors. It strips the power entirely away from their proprietary data gravity. It makes clinical safety and semantic comprehension a property of the network rather than a premium feature you have to buy from an individual software vendor.
It democratizes it.
You are turning a massive proprietary cost center into a shared public utility for patient safety.
It is the only architecture that provides a pragmatic roadmap out of the current silos.
Yeah.
It transitions the industry from a broken proprietary present to a highly liquid vendor-agnostic future. But as we've discussed at length, it requires organizations to be brutally honest about their current failures and rigorously validate their clinical safety mechanics before scaling. You can't skip the MVP.
Right, you can't build the network effect on a foundation of sand.
Exactly.
Man, what a journey. We started by looking at a $340 billion illusion, the idea that just successfully transporting a FHIR file syntactically meant we had achieved true interoperability.
An expensive illusion.
We explored the devastating clinical consequences of inert text, like those CDS algorithms failing, and the financial friction of the API write gap.
And we challenged the dangerous industry hunches that simply throwing more generative AI at the problem or moving legacy systems to a SaaS cloud would magically solve the foundational lack of a shared dictionary.
We unpacked the elegance of structural inversion, pulling the semantic brain out of the EHR entirely. We explored the mechanics of using AI as a fast suggestion engine, bound by a deterministic gatekeeper acting as an uncompromising checksum, and utilizing human informaticists solely for high-level governance of the exception queue.
The labor inversion.
The labor inversion, right. And finally, we looked at the multi-tenant dream Pathway C, where shared human learning drives the marginal cost of interoperability towards zero.
It is a profound shift in how we architect healthcare data. Truly profound.
Which leaves us with a final, slightly provocative thought for everyone listening to ponder today.
Oh, I like these.
If this vendor-agnostic semantic network effect actually reaches critical mass, if patient data is finally completely decoupled from the applications that generate it, if that data becomes totally liquid and perfectly comprehensible across any boundary,
then the application layer itself becomes a commodity.
Exactly. If the data flows perfectly, does the brand of the underlying legacy EHR become entirely irrelevant to patient care over the next decade?
It very well might.
Are we looking at the ultimate commoditization of these $40 billion giants? If the semantic layer provides perfect clarity, maybe it no longer matters who manufactured the plastic casing of the terminal the doctor's typing on. It is definitely a future worth paying attention to.
It's a fascinating and highly disruptive horizon.
Absolutely. Well, thank you for taking this deep dive with us today. Until next time, keep unpacking the innovation.